Hi guys, I'll just give a small demo today regarding this Excel V lookup formula. You guys have been wondering what to do with this formula, and what importance does it hold when you have applications for looking up into values automatically within a selected area or a selected range. Now it has a very big importance when your actual table here is a very big table, but I have shown a very small table here which has only a few descriptions with 6 numbers of descriptions, and we are going to look up for this particular value which is called efficiency from this reference sheet. This is our reference sheet from which we are going to look up for the efficiency values of a motor and select and enter in the load list automatically. So these values are getting entered automatically, and we are going to select the efficiency value from this cell using the lookup formula. Basically we are going to look up with 2 dimensions, which is 2-dimensional lookup. We'll explain Vlookup and then Lookup, and then we'll go and have a quick review with the match formula here. So basically before that I have to just make you understand what is this table first, so that you can have a clear view into the table and understand the formula better. So we have this motor sheet here which has different kilowatt ratings, and we have for each kilowatt we have different efficiencies according to the load factors. See, a load factor is basically nothing but the factor by which the entire kilowatt of the motor is used. See, for example, this is a load list here. In this load list we have different loads of the motor. The load connected to the motor may be a fan, or maybe a compressor, or maybe a centrifugal pump. Now motor is basically drawing electrical power and gonna give mechanical output, which the drive end, which is a centrifugal pump or a reciprocating pump, might use it. So the drive end, which is a centrifugal pump or a reciprocating pump might use the output of the motor, mechanical output of the motor, for on an operation. Now the pump requires mechanical energy which is drawn from the motor. The power output of the motor may be 3.3 kilowatt according to its nameplate rating, but the centrifugal pump here might not draw the entire 3.3 kilowatt of the motor. It might use only 3.27. Now this data is given by the pump vendor or the fan motor vendor who is supplying the drive end of the motor. He might give the power consumption, actual power consumption of the load and connected to the motor, which is called the brake kilowatt. The brake kilowatt is nothing but the amount of power used by the load end of the motor, even though the motor is slightly higher rated. Say for example, this is a reciprocating pump motor. The motor kilowatt rating is 5.5, but the reciprocating pump, according to the data given by the pump vendor, might use only 5.2 kilowatt of the 5.5. So the 5.2 is nothing but the brake kilowatt. Now if you see what percentage of 5.5 kilowatt is used here is 0.95 times. Says 95% of 5.5 kilowatt is used. This is nothing but the previous cell divided by this particular nameplate rating. So this is nothing but this value. The load factor is nothing but the factor by which the motor is loaded, and the efficiency value depends on two things, which is load factor and the kilowatt rating, as I've highlighted here in yellow. Here you can see these two also highlighted in yellow. Now let's see for 1.5. Here for 1.5 kilowatt we have different efficiency values for different loading factors. For the 1.5 kilowatt we have different efficiency values here. So our loading is only 1.4 of the 1.5 total 1.5 kilowatt. We are using only 1.4 kilowatts, so the load factor is 0.93. So for the 1.5 we have the load factor as only 0.93. So this is one particular dimension and this is one particular dimension. The intersection of these two dimensions indicates that our efficiency value is 0.83, which is automatically entered here. Now what if I change this value? What if the pump vendor or the cooler motor says that my cooler fan is going to use only 1.35 kilowatt of your motor? So the load factor drops down to 0.9 and this efficiency value changed by itself. I didn't have to do anything. And And now what if it comes back again during the second revision of the sheet? It says no, I was wrong and I was going to enter 1.4 kilowatt out of 1.5. So this load factor is again going to go up, and this efficiency is going to go up again by itself. I don't have to do anything. Once you enter the formula, it's just one click that you enter the value and it's going to change by itself. So what if the sheet itself was a bigger sheet? What if you had a bigger set of values here? Say for example, we are having some hundreds of rows here. Say for example, here it is 26 rows now, and I'll just go and copy from here and then just copy it 3 more times to get 100 rows. So I have just repeated those set of loads over and over again, and I have got some 100 rows here. What if these many rows were not just 100? What if these many rows were about 1000 or 2000? Usually in an industrial plant, in different sections of the plant we have different types of loads, and the load list is bigger enough to make you imagine like how am I gonna do the work if I was supposed to manually select the efficiency values from this chart. And now you have to say for example, just imagine in a situation you have to manually enter the efficiency values depending on the kilowatt and the load factor of so many thousands of loads here connected. Each and every time you have to look for what is the kilowatt value. Say for example, here I'm looking for 1.5, the load factor here, and then the efficiency. I have to go here and select it again. There you might end up in manual errors also. You might end up selecting the wrong efficiency also. So this is 100% accuracy and 1000 times faster. So in order to do that, you have to know what's a lookup formula first, and how you can copy the lookup formula into the other cells without changing the range using this dollar symbol. That's also some people face the trouble while copying the lookup formula also. So I'll explain that too, and I'll explain the reason why I'm adding a numerical value to the match formula, and I'll explain what's match formulas also. So for that, first let's look into the lookup formula. So here we have the lookup formula. If you click F2 in that particular cell, it shows what lookup formula has done with your cell. It has made two selections. One is the kilowatt and one is the load factor, because our lookup uses two references. One is kilowatt and one is load factor. So it is two-dimensional lookup using the lookup and the match formula. Now in the lookup formula, the first thing is it is looking up for sheet 2 D9. Now sheet 2 is here and D9 is here, which is 0.75 kilowatt. It's going to look up for 0.75 kilowatt in sheet 1 C9 to O19. You just ignore this dollar symbol as of now. I'll explain that later why I've added that. Now as of now it is going to look up for the 0.75 within the C9 to O19. Now let's just look up what's C9 to O19. Now C9 here, this is C9 to O19. This is our range of selection for the lookup formula. This is C9 to O19. It's going to look up for D9 in sheet 2, that is D9 in sheet 2, it is 0.75. Is going to look up for this value in the sheet 1's this particular range. Okay, now this is our range. It is going to look up for 0.75 here. Now this is our 0.75. It has looked up here till here. Now is supposed to return a value from a corresponding column, from a particular corresponding column, which is the efficiency values, which again depends on the load factor. So we have to first define what's the load factor, which is actually found by the match formula. So the match formula, what it does here, if you see the match formula, it opens up and it looks for sheet 2 F9. This is sheet 2 F9. This is F9. It looks up for the load factor. So this is the load factor here, and the match formula looks up for the load factor in sheet 1 D8 to O8. Now the D8, this is D8, this is D8, this is O8. This is nothing but a set of load values, load factor values I have entered here in the chart. Now this match formula will look up in your particular sheet what's the load factor. It is 0.92. It will look for 0.92 here. So this is our second dimension here, 0.92. and this is our first dimension, it is 0.75. The intersection is 0.8, so the value it should return is 0.8. Now how does it do it? I'll just explain the formula again. Now when it looked up for sheet 2 D9, here this is sheet 2 and D9, here when it was looking up for this value, it straight away went here in this particular range, which was nothing but C9 to O19. Here C9 to O19, it went here, and it was waiting for the match formula to tell which particular efficiency value I have to choose. The match formula told that the load factor here in sheet 2 F9 is 0.92, and the match formula directed towards this particular column 0.92, which is nothing but our 1 2 3 4 fifth column. It is showing that the match formula will tell the lookup formula to look into the fifth column and return a value of 0.8 to 0.75. Now I'll just make this formula a little simpler in order to make you understand what does the lookup formula does. I'll just delete all this. I'll just, for your reference, I'll just delete all this and again define how to look up use a lookup formula while in typing. For example, this is nothing, this was actually nothing. I'll just delete it. I'll just show you how to type the lookup formula. It is plus v lookup. Now I'm opening braces. You see the lookup value I'm specifying here. I'm putting a comma here, and I'm gonna go for sheet 1 and select this table array till here, and I'm gonna put a comma here. It will ask for the column index number, and now it is asking for which column I have to look up for this particular value of D9, which was 7.5. That particular column, it will be told by the match formula, which looks for the load factor. Now I'll open up the match formula, match match, and then I'll type this open brace, and then I will specify what the match formula should look into, which is 0.92, and for sheet 2 F9 is nothing but 0.92. I'll put a comma here, and I'll ask this match formula to look for this particular value in this particular sheet in this particular range. I've selected that, and the match type here, it is optional, it is not required actually. You can close this braces, and you should add a numerical value. Now I am adding a numerical value here as 2. I'll explain that later why I'm adding that. If you add a numerical value, the match formula actually returns the column index number to the lookup value. So right now I'm going to close this brace and end this formula here. So you're going to get an efficiency value here. It is 0.80, and I've added 2 here. I'll just explain that later. Here the value which is returned here. Now the difference in this formula, you see that I have not used this dollar symbol here. If I'm not using this dollar symbol, and I'm selecting this one and copying here, and I'm pasting in the next cell, you will see the 0.79 value, it might change. Now see, it is asking for reference. Now it is gone out of the formula when I am copying this formula without the dollar symbol. See, I am not having the dollar symbol. As earlier you saw, I was saying that there was a dollar symbol in the range specified. If I am removing the dollar symbol, you can just click the video timeline and drag back along the timeline. You will see that there was a dollar symbol here. Now it is not there. When it is not there, and I am selecting that and I am copying it in the different cell, it is asking for reference because the range has changed. Now see, the previous range was D8 to O8. Now here it has become D9 to O9. The range itself is changing when I am using the copy paste formula without the dollar symbol. Now see, here it was C9 to O19. Here it becomes C10 to O20. The O20 here is nothing. It is an empty cell. The O20 is empty cell. When you copy this along again to a different cell, now that O20 becomes O21. The range keeps changing. If you paste here, again it becomes O22. The range always keeps changing, so we don't want that. So I'm going to delete this one, and in order to avoid the range change, what I'm going to do is fix the range using a dollar symbol. I will say Excel, I will ask Microsoft Excel, when we copy the formula, don't change the range. For that you have to fix the range using a dollar symbol everywhere. the address, just before that you have to keep entering the dollar symbol wherever the ranges are specified. So you have the dollar symbol specified here and press enter. Now this formula remains the same, the value remains the same. This is the formula. It looks up for D9 here, which is D9 0.75. It looks up for this value in sheet 1 C9 to O19. Here it is C9 to O19. Within this particular value, it looks up for 0.75 kilowatt and fixes its cell here, and it waits for the match formula to tell what is the load factor. 0.92 is the load factor, and it will say 0.92 is the load factor 1, 2, 3, 4, 5th. And from the 5th column, it will ask the VLOOKUP, the match formula here. It will ask the VLOOKUP to return a value corresponding to the 5th column, which corresponds to the load factor 0.92 for 0.75. So it will ask the lookup to return an efficiency value 0.8 exactly. So it is the return value. But the difference being, I have fixed the range using the dollar symbol, so that if I copy this and paste into the different cells, we have the values now. As I said a while back, it was asking for reference because the ranges were changed. Now if I'm using the dollar symbol and copying it to different cells, you see here it was C9 to O19. Now it is again the C9 to O19 itself, because I have fixed that range using dollar symbol, and I asked Microsoft Excel not to change the range values when I am copying this lookup formula down the line along the column for all different rows. So your range is fixed by the dollar symbol. That's what's the importance of the dollar symbol. And I was gonna tell you why I'm adding a numerical value here. Now why I'm adding a numerical value here, I'm gonna do one thing here. I'm gonna confuse you. This is the first row here. I'm adding a value of 2. This is the second row here. If you see, this value will be wrong, because see, for example, here it is 1 kilowatt and it is load factor is 0.9. you see, for a load factor of 0.9 for 1 kilowatt, a load factor of 0.9, the efficiency value is 0.79. Now but the value is 0.80, which is nothing but this next column value. So I have a number less added, so I'm gonna have just 1 added, so that it is 0.9. now it is right. Now I'm gonna copy this and paste this throughout everywhere, so we'll get the exact values. Let's just cross check. It is 3.3 kilowatt for 0.99 loading factor. So we have 3.3 kilowatt for we have 3.3 kilowatt, sorry, we have 3.3 kilowatt for 0.99 loading factor, 3.3 kilowatt for 0.99, it is 0.91, the efficiency is 0.91, and here we have the efficiency 0.91. again, it's right, just because I added a lesser value. But in the first column, in the first row, I added a value 2. See here, the kilowatt rating is 0.75, and here the load factor is 0.92. 0.75 and 0.92, the two dimensions, to return a value of 0.8. In order to have that correct, I have to add 2. Now say for example, I am not adding anything and then just entering that, my value is wrong. Now see, it's saying it is 0.78 instead of 0.8, which is 2 columns behind. So by default, there is a fact in this formula of two-dimensional lookup using match formula, that for the first row of the table, it looks up for 2 columns lesser. So you have to add 2 to that, and thereon it starts looking for the column 1 column lesser. So you have to add just 1. So this is the explanation why you have to add 1 and add 2. It is just for adjusting the column reference number while you are cross-checking for the values. Now let's just cross-check. It is, the formula turns out to be as such that you're going to use lookup and use the match formula to tell the lookup formula in which column to look up while returning the efficiency value using the load factor dimension. Now the addition of this numerical value is 2 for the first row and only for the first row of your table, and thereon you have to add just 1 for the entire, throughout the entire table. Say for example, there are 101 rows here. I'll just clear your doubt very easily. I'm selecting this particular cell. This is the efficiency of 0.87 returned by this formula. Here also in the nth column, in the nth row, it may be 1000th or it may be 2000th or it may be 5000th row. There also you have to add just 1 to the match formula and tell the lookup formula to return a value corresponding to this particular column added 1 with respect to this particular kilowatt rating, which is D104. It is D104, it is 5.5. Is going to look up for 5.5 inside the range of C19 to O19, which is C99 to O19. Here it is going to look up for 5.5 kilowatt here, and it is going to wait for the match formula to tell it which particular column it should look into for the efficiency value and return. Now the match formula will tell you do look up for this F104, which is F104 is 0.95 is the loading factor. Here you have the 0.95 as a loading factor. It is in the column number 1 2 3 4 5 6 7 8. It is in the 8th column, but you have to add 1 to this value to make sure that it returns a value of 0.88 here. Now the reciprocating, this is 0.87 here, 5.5 and 0.95, 5.5 and 0.95 to 0.87 it's entering it's supposed to be 0.88. Now you're having 0.87. Now what if I'm adding 2 here? It is 0.88 exactly. Now it is the formula is correct. So here if you see 3.3 kilowatts, and it is load factor 0.99. so again you see 3.3 kilowatts and the load factor is 0.9 and the value is 0.91, and here the value is again correct. It is just 0.91. I have to just add 1, but here I had to add 2. Why do I have to do that? Because the values here that I have entered, it is 5.5 kilowatt and it is 0.95. you see the 5.5 kilowatt and it is 0.95 is gonna have this 0.88 return, and it didn't have that return when I was having 1. When I was having 1 here, it didn't have that return. That's why I'm adding here as 2. Now how to identify that particular cell where you are gonna have the wrong set of values? Say for example, I'm gonna look for this one, 0.55 5.5 kilowatts and 0.95 here. The efficiency value is 0.87. again it's wrong. Now see 5.5 kilowatts, it is 0.95. it should be 0.88 now, but it's returning a value of 0.87. so I'm gonna add 2 to here to make sure that it is correct, and for the rest of the values it's just the same. In order to avoid these kinds of confusions, what you have to do, in order to check out, you have to add 1 or 2. What you can do is use the filter formula to avoid these confusions, and you can use this filter here and filter it so that now here you can choose the rating values. See, for this entire table I'm selecting just 0.75, and you're having just one number of 0.75. That's actually, yeah, that's correct. And here if you see the 1 kilowatt motor, you're having so many 1 kilowatt motors. Now for all these 1 kilowatt motors, the brake kilowatt is this much, and you just check just 1 kilowatt and this 0.9 loading factor. The efficiency is 0.79. Just check it. 1 kilowatt, 0.9 is the loading factor, and 0.79 is the efficiency value, so it is correct. So you don't have to add 2 here. This 1 is correct. So I have minimized one mistake, and I'm going to select all, deselect all, back again, and I'm going to go for 1.5 this time. 1.5 here shows a load factor of 0.93 everywhere, so 1.5 here, 0.93 everywhere, it is 0.83. so I'm getting 0.83 correct, so I'm going to use +1. so I'm going to go this way for 2.2 kilowatts with a loading factor of 0.95, 2.2 with a loading factor of 0.95, 0.86 should be returned. Now here this value is correct, so I'm going to add leave that as addition of 1 to the value. I'm going to go do this again for 3.3 kilowatts, and 3.3 has a loading factor of 0.99, which is just the value previously to 1. Here 0.99, you should return a value of 0.91, which is nothing, but here you have the value again correct, it is 0.91. so I'm going to leave this as just 1 added to this match formula. And now we were talking about a mistake that happened in 5.5 5.5 kilowatts. Everywhere, wherever there is 5.5 kilowatts, we have a mistake here. Just cross check that. It is just achieved by cross checking that value. So this 5.5 kilowatts here is having a load factor of 0.95. So the if you see this 5.5 kilowatts is having a load factor of 0.95. Now the value should be 0.88. Now here it is only in one particular cell where I have added 2, it is showing 0.88. For the rest it's showing 1. Now this is a mistake that has occurred. So in order to correct that, we have to add manually here as 2, and then copy this and select everywhere else in the row. This is the mistake that is identified and corrected. So whenever you use a formula in Excel, this is how you have to cross verify. Even if your formula is 100% accurate, you're 1000 times faster, maybe sometimes these are all the errors that Excel might occur. These are all the default errors that Microsoft Excel has within those formula themselves while using. So in order to avoid those things, see, there are a lot other things also that Microsoft has errors about. I'll just show you here. If I'm opening a new window here and I'm typing here, I'm opening a new folder, I'm trying to name it as con. Okay, I'm entering that. The specified device name is invalid. I mean, who the hell are you to tell what I can type and what I cannot? I can use this name, right? Why am I not able to use it? I pressed enter. It's not allowing to name this. See, the specified name is invalid. I have to rename it. When I am renaming it as con again, it is actually saying the name is invalid. So I can't, there are some things in the products of Microsoft that you have to go by default and accept their flaws. So the flaw here in this formula, it doesn't actually apply correctly to everyone. In order to rectify the errors of this formula, you have to select this filter option by yourself. So that can be done pretty easily. It is just selecting and deselecting everything. Even though this sheet is of thousands or 5,000 or 10,000 rows, this just one click operation is going to identify each and every type of rating. There might be only some 10 to 15 types of ratings. For each type, you go and select that and see whether the efficiency values are returned correctly. If they are not returned correctly, simply you have to just add a particular numerical value to that, the match formula, to say the lookup formula from which corresponding column you have to enter the efficiency values. You have to return the efficiency values correctly. So for the 5.5, we identified an error using the load factor of 0.95. For the 5.5, using a load factor of 0.95, the efficiency was 0.88, but here initially it was 0.87. If you drag the video timeline previous section, you would see that it was 0.87 wrongly when it was just 1 added here. Instead of 1, you have to just add 2. So by this is why I used to add a numerical value to the match formula, and this is how you identify the mistake by this filter option. Doesn't matter if this sheet is of 10,000 rows, the filter option drops down the particular kind of ratings here, which might be less, because mostly the ratings get repeated over and over again. So you might have only a few types of rating. For each type, you select one particular type and come here and cross check the efficiencies manually. It is a very simple job. If you're not getting the exact value corresponding to that rating, you just have to go and add a numerical value to that in order to make sure that your values has been returned correctly. So this is how I ended up adding a numerical value of 2 here for the first row, and for the rest of the rows by default it goes by adding just 1. So this is how it works. But in some cases you have errors here, like I identified for 5.5 kilowatts. In that case you have to just manually select here and then just cross check with that. So if as earlier as I said, this lookup formula, you can add just 2 to the first row. By default the first row is always a wrong value returned to the cell. So you can add a value of 2 there to avoid that error. For the first row it always happens. For the other rows, adding just 1 returns the exact column index number and tells the lookup to return the exact efficiency value depending on the rating of the kilowatt rating of the motor. For that you have to just add 1 in, for that operation to happen. But throughout the entire range of the rows of the sheet, and maybe 10,000 rows, for all the rows you have to add just 1. But in some cases errors might happen. In that case you have to just use this filter option, deselect all, and identify one particular type of rating where you had the mistake, and you can add 2 to there, so that you can you can get the exact efficiency values returned to that particular type of rating. So this is how you identify the errors in the formula, and this is how you use this formula, and this exact numerical addition to that particular error rectifies the error and returns the exact efficiency values. Now if you would ask me, what is the use of doing all this? The pump vendor might just come and say that, oh okay, now my brake kilowatt ratings for this particular set of values have changed from 1 kilowatt to 5.5. they have completely changed. Now he might keep entering values like 0.95, which is slightly higher. This 1.45, which is again slightly higher. This might be lesser, like say for example 2.05, which is slightly lesser, and this is 3.2, slightly lesser, and is 5.2, this 5.25, which is slightly higher. Now see, the efficiency values changed automatically. Now what would happen if these particular set of values get repeated over a certain area of the sheets? Like say for example it is here from 1 to 5.5, the brake kilowatt has changed and the efficiency value changed. Now what if it happens for these certain areas of the cell? For example, from here it happens. Now here we have this again changed, efficiency value is changed. Here if I keep this and paste this again, the revised data, the efficiency value will change from 1 to 5.5 kilowatts. The efficiency value changed. So this is how this formula aids you. It is just a one-click kind of help that you get from Excel. Just one click, and you just paste those values, revised values, the efficiency values revised by themselves. You don't have to again look in for manually each and every time. This is how you come towards perfection of rectifying the errors in the formula itself and using the formula itself. Until next time, goodbye.